A baseball team plays in a stadium that holds 55,000 spectators. With the ticket price at $10, the average attendance at recent games has been 27,000. A market survey indicates that every dollar the ticket is lowered, attendance increases by 3,000. Find a function that models the revenue in terms of ticket price. Find the price that maximizes revenue from ticket sales. What ticket price is so high that no revenue is generated? For part A, to find the revenue, in economic, the revenue is the quantity times the price. And so if we want to find the revenue, we need to know how many tickets sold, and then we multiply the price per unit. When we read this question but not carefully, it is very easy to make a mistake that the price of the ticket is $10. The market survey indicates that we can increase the number of tickets sold. In fact, for every dollars that the ticket price is lowered, attendance increases by 3,000. We have to make the assumption that in economic terms, we want to maximize the revenue. We want to sell more tickets. Because of that, we do not know what the price is. And so, we will let X be the price of the ticket for now. And so for each ticket, it will cost X dollars amount, X per ticket. So this is the price. With this new price, we will find the quantity. We are given that so far, past records show that if we were to sell the tickets at $10, then attendance will be 27,000. The survey shows that if we were to lower the tickets by $1, say to $9, then the ticket sales would increase by 3,000. And so this number of tickets will be now 27,000 plus 3,000 is 30,000. Increases by 3,000 if we were to lower it by 1. Similarly, if we were to decrease the ticket price by $1 more to $8, then the number of tickets sold will be 33,000 at another 3,000. At the current price of X dollars, which we don't know what it is, we want to know what the number of tickets will be. We always start with the initial value, 27,000, and we add it. Notice that if we were to increase by 1, then we would add 3,000. If we were to increase by 2, then we would add 2 of 3,000. And so if we were to increase to X, which is the difference of 10 minus X, then we would increase 10 minus X times 3,000. And again, from 10 to 1, the difference is 1, so we only add 1 of 3,000. From 10 to 8, the difference is 2, so we would add 2 of 3,000. From 10 to X, the difference is 10 minus X, so we would add 10 minus X times 3,000. This is the number of tickets sold if the price is X. This X is the price and this is the quantity. Put this together, we will have the equation for the revenue. The revenue is therefore the quantity, which is 27,000 plus 10 minus X times 3,000 times the price, which is X. Let's simplify this. This is 27,000 plus 3,000 times 10 is 30,000 minus 3,000 X times X. 27,000 plus 30,000 is 57,000 minus 3,000 x times x. And so this is 57,000 x minus 3,000 x squared, which is a quadratic equation. Put it in the standard form. This is negative 3,000 x squared plus 57,000 x, where a equals negative 3,000 and b equals 57,000 and c equals 0. Again, this is the revenue in terms of x. B. Find the price that maximizes the revenue. This equation represents the revenue, and this parabola concaves down, and so the maximum revenue is the highest point, or the maximum. And the maximum, if the graph is concave down, the maximum occurs at negative b over 2a. This is negative 57,000 over 2. A is negative 3,000. Put it in the calculator. We will get 9.5. This is the price that we should charge to maximize the revenue. C. What ticket price is so high that no revenue is generated? No revenue is generated when the revenue equals 0. So we set the equation negative 3,000 x squared plus 57,000 x equals 0 for revenue equals 0. And we solve for x. Factor out x. We have negative 3,000 x plus 57,000 equals 0. This is a zero product, so we would have x equals 0 or negative 3,000 x plus 57,000 equals 0. X equals negative 57 over negative 3, which is 19. At the price of $19, there will be no revenue generated.